Hi, I'm Hassan Akmi and I'll be updating you about my OOP progress till this week. So what I've done up till yet is that these are all my files, and here in my main I'm making objects of my void class, and basically I'm giving the position, and here I'm giving a character array. Basically this is a character array, and it is uppercase. It converts all the lowercase into uppercase. All the calculation is being done in that void class. And then what is happening here, and this is basically object of my button. Basically it calculates the length of button, and according to that it creates a button on the screen over which the word is then drawn. Okay, so when this is my mouse event, here mouse events are occurring, so let's run it. 1 2 3 go. Okay, so as you can see, it's according to the length of the word, it is making the button plus here you can see this word is little towards left as compared to this word. So these calculations are being done in word class plus this. Okay, now the mouse event thing, if I click on this, so it changes to this, and then if I again press escape, so I can be back to this, and if I click on this, so this, and then I again escape, and if I click on quit, it ends.
So last week you saw me working on the break functionality for this game. This week I improved it up a bit. So you remember that the logic of this brick generation is such that the player has to input certain numbers onto a txt file, and after the program reads that txt file, it will generate corresponding game screen for the user. So that was working fine in last week's video, but this week what I'd worked on was that I generated rows. So if, for instance, my user presses the enter key, this means that another row will be generated. So now if the user does enter anything, it will not be in this single stream. In this single stream, it won't be attached to the single stream, rather it will come onto the next row. After that, what I did was that I worked on the invalid type of keys that my user does input to crash my code. So these invalid keys are being handled such that they'll be ignored by my program. So if, for instance, if I do enter these letters, they will be ignored by the program, and in place the program will just show spaces, and that's it. The third thing that I worked on was that if my user does input valid stream of numbers, what it will do is that my program won't generate all of those valid numbers. Rather, the bricks will be generated such that they do not exceed the game screen, which this was not being done previously. So let's see how things work. So you see, no brick is being generated in this region, even though there are valid numbers here and in this row and in this row. Why so? Because the brick being generated here, that should be generated here, exceeds the screen width. So this is done. For next week, what I plan to do is that I plan to work on the power up section for the paddle, such that if my user presses a key, the paddle becomes larger or smaller. So that's it. Thank you.
So hello everybody, this is the third video for our game Arkanoid. In this week I implemented in file I implemented bricks. As you can see in deserializer I've incorporated the multiple types of bricks. So since we have more than one type of brick and every brick will be destroyed at different types of hits, at different number of hits, so we have incorporated different bricks. As you can see, brick 1, brick 2 and brick 3, which are corresponding to different types of file. Let's run this game and see how it's running without deserializer or without file reading. This is the game, it's being run now. Let's check how this game will work with file deserializer option, which I have implemented this week. So I have commented out in the main the part of the code which was creating new bricks and new ball and object, and here I have actually activated the file deserializer, which will run the game from where it was left off in the previous run. Let's see. So you see the battle was on the left side, so then now ball is on. Let's just investigate again where the ball is in the middle of the screen. See, the ball bounced up from the same position where it left off in the previous game. So this was the task of this week's goal.
Hello everyone, this is my 4th week update for my project. This week I was working on homing bullets and the user interface. I would like to show you the code of homing bullet first. This is my homing bullets H file, and this is the CPP file. For homing bullets, you have to figure out the theta. First of all, you need to have 2 points, the point from where you have to shoot the bullet and the point where you have the target. Then you find the x distance between both the points and the y distance, and with the help of that we look for theta. This is where I'm calculating theta in the form of pi. As soon as I find theta, then I will be using x and y in this form, where I will be adding cos theta in x and sin theta in the y. And theta will be updated after every point. And when I would like to run this, if I run this is the splash screen, and this is where we can shoot bullets. This paddle will only shoot homing bullets for now. I have given the paddle half length. The point where the target is for right now is hardcore. The target is in between of the screen. If I start shooting the bullet, there are certain problems that I have to figure out. The bullets do not get deallocate as soon as they reach the target. This is where what I have to figure out, that as soon as the bullet reaches the target, and if any collision happens, the bullet deallocates as soon as possible. One more thing that I would like to show you is the health bar file and the score file that I have made. 1 minute, I will add it to the folder. This is the score H file. It's in bitmap. I have to make it go to L structure. One more thing I would like to show you is the health file. Okay, so this is the H file of the health bar, and this is the CPP file. I'll show you what sprites I am using for this file. Okay, so I have to figure out small things in this, as health will be we will have initially 3 balls, and as soon as one ball moves out of the screen, the user will automatically get another ball on the paddle. So these are the sprites that we are using. So sorry for that. So the picture that I am using is, I will be using these 3 balls. They will appear on the user interface up above the game and will update the user how many balls they have left. Um, I think that's it for my update for this week. Thank you.
Hi guys, my name is Joseph Abdi and this is my fourth update video. So let's check what updates do we have in this week. So let me just play the game, and as you can see that in this week I got bricks which were not present in the previous video, and I let them work. It means that whenever a ball hits a bricks, the bricks get deallocated. And also let me just show you the collision function. In the previous video I make the collision function in the main function, in the main file, but I update that function and make them in the list and make a generalized function. As you can see here, here is my check collision function, and it is a generalized function. It takes two inputs, object 1 and object 2, and check whether they are colliding each other, and if they are colliding each other, the collision is get true. And since there are only two types of collision, ball paddle collision and ball bricks collision, then it will okay. And also I try explosion characteristics, that whenever a ball hits a bricks, the explosion occurred, but unfortunately I'm unable to build up that, but I make an explosion function now. Whenever a ball drop the screen or whenever a ball fall, there is a collision occur and a new ball came in. So this is all that I have in this page. Bye.